something that you have seen in the past. This is something that is not going to be completely scary new. Law of science. I try to have that theme song every once in a while. Law of science. You did this last year in geometry. And if you remember that from last year, and even the kids that did it this year in geometry, it was one of the easier formulas, easier setups that we've done. Most people fly through the law of science. Remember, law of science is nothing more than this simple proportion. Proportion is just more than one ratio set equal to each other. Law of science looks like this. In any triangle, it's not a right triangle. Where's that law of science? The sine of angle A is to the side opposite. Is to the sine of angle B is to the side opposite. Is to the side of angle C is to that side's opposite. Or if you flip all the fractions all the way around, they're also still equivalent. The book, the advanced algebra book, likes to show you the flip. I could care less, to tell you the truth. It doesn't matter. I'm always going to go with the generic sine of A is to A, sine of B is to B, and so on. Now, one of the things you want to remember when you do in law of science is what's going to change now in advanced algebra is that it's not always going to work cleanly. Last year we had law of science that worked every time. You guys pretty much ran through it without too much of a hassle. First things first though, what do you think your calculator mode should be in for law of science? Degrees. If your calculator, you guys don't remember how to check the calculator modes? Put them in degrees right now to make sure you're okay. That way we don't get negative side lengths somehow. And you didn't have negative side lengths, I hope. So here's what's going to happen. When you're dealing with the law of science, you had to have one of two scenarios. In order for law of science to work last year, you had to have either angle, side, or angle, side, angle. Do you remember what that meant if I said angle, side? When I say angle, side here, what I'm talking about is two consecutive angles and one side opposite a given angle. Angle, side, angle. Two angles and a side between them. Because in order to use the law of sines, you have to know an angle and its side opposite. If I have two angles and a side between them, how do I find that third angle? Well, how many degrees are in a triangle? Yeah, you subtract it out to figure out this angle. So that way you get this angle here and the side opposite. Okay? Now, these are the two setups that you guys had solely last year in geometry. Wasn't anything too scary. All right? So let's take a look at an example. We'll come back to this. Whenever you are given a scenario for, solve the triangles, when it says solve the triangle, that means you have to do what? Yeah, find all the side lengths and angles that's missing. In order to figure out what that is, what should you do right away? Draw a triangle. Okay? Does it have to be beautiful and perfect? No. A, B, C. You're given angle C, 103. You are given angle B, 28. And you're given the side opposite B, 26. When I'm looking at this, that means I have to find three things. Looks like I got to find an angle and two sides. What's the angle I have to find? A. So what I want to do is start making a list of things I need to solve for. I got to find A. I got to find little a. I got to find little c. Remember, the sides opposite are the lowercase letters. Does everybody agree with that? What's the easiest one to find right away? Angle A. So what do you get for angle A? Does everybody agree? Add up the other two angles and subtract from 180, you get 49. So right off the bat, I'm a third of my way done. Okay? Now, in order to do law of sines, I have to have an angle and a side opposite it right away. What angle and side opposite do I know right away? B. I know this setup here. So what I do here with law of sines is that I'm going to use sine of angle B is to the side opposite it to solve for A and C. I use law of sine twice, and I write it out. So I have the sine of 28 is to 26 as the sine, we'll find A first, of 49 is to A. Everybody okay with that? No, this is just plain straightforward science. It's not worrying about SOHCAHTOA because that's where you're looking at right triangle trig stuff. We're out of the right triangle for right now. From here, whenever you have fraction equal fraction, what do? Yeah, good. So you cross multiply out and just write everything out. Don't try and shortcut it. You have A sine 28 is 26 sine of 49. Now remember, sine of 48, sine of 49, 28, sine of 49, those are just numerical values. I don't care what they are. They're just some number. I'm going to figure out what the whole value is later. Let the calculator do all the work. Right here it says A times the sine of 28. How do you undo that? So you divide both sides by the sine of 28. So I know that A is going to equal all that. So here's where you have to be. Here's where you're going to have to be able to use your calculator. So in my calculator, what I'm going to type is 26 sine 49 and hit enter right away. Now divide by sine 28. The reason why I'm hitting enter between those two, between the division part, is because 9 times out of 10 you're going to forget to close the parentheses on the numerator, and you will be wrong, and you won't realize it. So take care of the numerator, hit enter, divide, and then hit enter. It alleviates the issues that you guys usually have. Okay, it's a nice, easy way to remember it. So that means that side A is, remember, we round 2 decimals, 41.8. 79.6 rounds up to 0.8. You agree on that? So I know that side A is 79.8. Was it 49? Yes. Oh, I'm sorry. Where did I get 79? I was looking at something. I was looking at 79 here. Sorry. So it's 41. 0.8, yeah, when you round it up. That's why I was getting to 79 because I saw. I'm old. Okay. Now, in order to solve for side C, reuse the 28 and the 26, and then just use sine of 103 as the side C now. I'll just move this bit over. So once again, sine 28 is to 26 is the sine of 103 is to side C. And hopefully over time you'll start to realize that the algebra is very similar for most of these problems. You might start to see some of the shortcuts that will occur, but I'll rewrite it out again. C sine 28 is 26 sine 103. And then just divide out. C is going to equal all that. So once again, in the calculator, 26 sine 103 divided by sine 28. Did you guys get 5396? Now, yeah. Do you guys remember how to tell if you're even on the right track? Yes. Your angles and your sides. Explain that further.
Like, if 53.96 is on C, and since that's connected to the bigger sides, the bigger number, it should match the bigger angle.
Good, very good. Remember the rule, guys. Largest angle should always have the largest side. Smallest angle, small side, and medium versus medium. Okay? What happens if the two angles are the same? They should have the same side because what kind of triangle is it? Isosceles. Oh, here we go again. Is an equilateral triangle isosceles?
Yes.
Is a square a rectangle?
Yes.
See? They can be taught. Yes, circle and ellipse. We'll get to that one. Remember, yes, we will be dealing with circles and ellipses. Ellipsi? Ellipses. Ellipses. Are you guys debating the square and rectangle thing?
No.
Remember, a square is a rectangle, but a rectangle isn't a square. What's that? You think it's backwards? Stop. How's that for an answer? Just stop doing that. Now, like I said, since this is advanced algebra, does everything always work this nicely? Oh God, no, we're jerks. We like to make things mean. So we have to do this. Don't write this down. I have got a really nice little... Yeah, I know. Yeah, that's right. You're the happy person, right? The land of fuzzy bunnies and flowers. Was it fuzzy bunnies and fluffy clouds? So what I have on this sheet here, I'm going to explain to you guys what happens. Because not always does everything work cleanly, unfortunately. Sometimes math is a very, very, very mean thing. Sometimes, yes, okay. No.
Yes.
What's 2 plus 3? See, math was happy to you there, right?
I still have trouble
Here's what happens. Right now, we're discussing within the law of sines. We're discussing the law of sines. The cases that are always nice and easy to work is when you have your two angles and a non-included side, or two angles and the included side. Sometimes you have this. Oops, whoa. Sometimes you have this scenario. Sometimes you have two sides and a non-included angle. If you have two sides and a non-included angle, it's side-side angle. Remember, in geometry, we said this doesn't exist. You can't prove things are congruent via this, but I'm just showing you that in this scenario, if you are given two sides and a non-included angle, there are certain things that can happen. The certain things that can happen are one of these 6 things. Now, it breaks it into 2 very easy things to look at. On this chart here, what they're giving you here is little a, little b, and big A. What that says is the large, or the given angle and side opposite, and then another side. Okay? It's the two sides and one angle opposite one of the sides. All right? Now, they're generically written out as little a, little b, and big A. Is it always going to be little b, little a, big A? No, it could be little a, little c, big C. It could be a mixture of all of them. If there was every single possible scenario, this would be a lot more paper. So what we're going to try and do here is just look at it as the given angle and side opposite. Remember, this is going to be the given angle, and this is the side opposite. Big A, little a, on this chart. Okay? So we're going to refer back to this chart a lot, because this is the new stuff. let's look at an example of where this goes with. Single. Once again, first thing we're going to do whenever you're given some values is draw it out. So we have triangle ABC with angle C is 122. Okay. So angle C is 122. Little a is 12, and little c is 18. So in this case here, we are given the angle C and the side opposite it is the little c. Those are the two angles we're given. The opposite, the other side is side A. Everybody agree with me on that? It's 122. There's the angle C. Is that what you're looking for, Jake? So now what I do is I look at my chart. And on the top of this chart, you have two questions to ask yourself to begin with. First question, is the given angle obtuse or acute? Obtuse. So the given angle here is 122 degrees. So that means that angle C is obtuse. So angle C is obtuse, which means what are the two possible scenarios that I have to look at? Well, I have to look at to see if the side opposite angle C is smaller than B, or smaller than the other side, or is it bigger than the other side? So I write down the two values. Well, the side opposite is 18. The other side is 12. Since it's bigger, that means I can have one triangle. One triangle happens. Now that I know that one triangle can happen, what do you think I do? Solve it. Figure it out. Okay? So what's going to happen here today is that not always will every case be something that's going to work right away. You may have to go back and double check to see how it's going to work. That's all. That's all. Okay? So now I know that I have the sine of 122 is to 18, as the sine of angle A is to 12. And I really want to make sure you guys understand how you find a missing angle. If you recall from last year, even in geometry, when you had to find the missing angle, this is where a lot of you guys had some problems. What button on a calculator allows you to find the angle? Second sign. So it's the inverse button. So what I'm going to do here is I'm going to get rid of the 12 to the other side, just by multiplying. You okay? So I'm going to get 12 sine of 122 is to 18 is the sine of A. The rest of the problem is calculated. But show me what it's going to be. Okay? So I take my calculator out. I'm not there yet. I'm going to get there. First thing I'm going to do is type in 12 sine 122, hit enter, divided by 18. That means that this decimal amount equals the sine of A. You agree? In order now to figure out what A is, our calculators are smart enough to understand how to store values. All you have to press are the following sequence of buttons. Second sign to get you the inverse of your answer. The answer button is the negative symbol down on the bottom. Second answer, and now hit enter. There's your angle. 34, 43. A palindrome. Palindrome. Same number forwards and backwards. Like today's dates, I was just informed. 3/13/13. Oh, yeah. It's not going to happen again until next year in April.
If you want to think of numbers,
race car. It's probably the same forwards as it is backwards. Yes, it is. 34. I'll be rounded.
Remember, we rounded to 2 decimals. 34.
It was just looking at the number.
All right. So now I know what angle A is. How do I solve for angle B? Add them up, subtract from 180. So 180 minus 122 minus 3443 gives you? 2357. Now, how do you think you're going to have to solve for side B? Law of sines. Yep, sine of 122, again, is to 18 as the sine of, what was it, 23, 57 is to side B. Do you want me to continue doing that problem, or do you okay cross multiplying solve now?
Can we keep that number?
No, I just rewrite it, because now you're rounding, and it's going to be a little bit through. It's okay. Okay? Yeah. So remember, when you get this far, you wind up with B should equal 18 sine of 2357 over the sine of 122. That should give you the value of these. Okay. Not so scary. The 23 is angle B. Remember we found that from subtracting out from 180? Because we figured out we had 122 and then we found angle A. So we just subtracted them through. That's all. So let's look at another one. Triangle ABC. You have side A, side B, angle B. First things first, draw your diagram. Angle A is 4. Yeah.
So I'm seeing units. Do you want to separate or put that in my routine?
It's not the end of the world. If it's a word problem, yes. If it's not, eh. Lori, get there. So in this case, you're yeah.
So if we went to the other problem, if we were going to send a some other maybe you just stop.
Correct. Yeah, you just stop. That means you can't make a triangle out of that. With that given information, it won't work. Okay. So here we've got 2 sides and 1 angle opposite. So it's the side-side angle scenario again. So I know it's a side-side angle. I have to go to my sheet. Now the angle that we're given, is it obtuse or is it acute? It's acute because it's little. Okay. Now, it being acute, there are There are 4 scenarios that could possibly happen. Does it matter which one you check first? No, but just pick the first one. So here's what this says. When it says B sine A greater than A, remember, this value is the given angle, and this is its given side, the side opposite. This guy is just the other side. So it's not always going to be side B, side A, angle A. In this case, you have angle B, side B are the ones that are opposite. I do. Street. All right. So here what we check is, well, I know that it's going to be the sine of 58, and the sine opposite is 2.5, and I multiply that by 4. Okay. So just check it in your calculator. Is that a true? Is it true or false or what? It's true. What do you get? Like 3 something?
139.
Last time I checked, I'd rather have $3.39 than $2.50. So can I have a triangle? No triangle. Go to the next problem. That's what that means when you have these acute triangles, these acute angles. You have to check them. You have to walk through them. Okay? There's going to be a bunch of different scenarios you have to check. Okay? Yes, ma'am. I know. That's. Remember, this is just a generic form. Remember, this just means given angle and the side opposite it. All we're talking about here is that B is the given angle, little b is the side opposite. So this means, if you want to rewrite it this way, think of it this way for the acutes and stuff like that. This is the sine of given angle greater than side opposite given angle. And this is the times other side. Does that make more sense? If you want to break it into something more generic, that's kind of what they're talking about for all of those A's and B's and stuff. Okay? Yeah?
So, if you have a problem with not the opposite,
Well, if it was given and not the side opposite, then you're going to wind up probably in one of these scenarios. See what I'm saying? Yeah. Because you'll probably, there's only 2 things that'll happen. You're either going to be able to do law signs right away, or you're going to have to ask a question. That's all. Does that make sense? It's like playing Plinko. See that on Price is Right, right? You drop it down and go.
yeah.
When you guys are home sick, you don't watch Price is Right?
No, they're.
Would you like my little sick? Yes, ma'am. If it was, now here's the thing: if it was smaller, then I go to the next one. Then if it was not true, then I try the next one. Is the side, the other side times the given angle equal to the given angle side opposite, or I check the other ones. So there's all these other ones you got to check.
Okay, so where it says the sine A, whatever, is that like where we have to do the inverse of the angle?
No, because you're going to be given that angle. This A value is the given angle. You don't have to do any inverses here. You don't have to do any inverses until you get into that law of sines, if you have to find the angle itself. Here you're just going to be dealing with the given angle, the given value. That's all, just to check to see if any of those 4 are going to work. All right? Let's see here. Sometimes my given angle is A, and the side opposite it is little a, and the other side is C. So I'm labeling out the 3 possibles right away. Is the given angle acute or obtuse? It's acute. So the given angle A, it's acute. So since it's acute, the first thing I'm going to check is what we just did. Well, I'm going to check and see, is the other side opposite 160 times the given angle's sine, is it larger than 155? I hear a no. Okay, so that doesn't work. I go to the next one. Is the side opposite, the other side, the 160, times the sine of the given angle equal to the side opposite the given angle? I hear another no. No. I go to the next one. See what I'm doing here? I'm just going right across the list here of which possible scenario am I going to wind up with. Okay? I check the next one. Is the side or the the other side, gotta know how to say it, times the sine of the given angle, is it smaller than the side opposite and smaller than the other side?
Yeah, that's true.
That's true, because what's this value here? Would you guys, how much?
150.
So it's 150 is smaller than 155, which is smaller than 160, which means how many possible triangles could we wind up with here? 2. We could have 2 possible triangles.
So are we gonna solve the 1.1?
Yeah. I think for today, if you get a 2 possible, let's leave it at 2 possible for right now. I'll explain to you guys tomorrow how you solve the 2 possible. It's not that difficult. I just don't have, because it's Wednesday and we're running a little short. Okay. So if you do come across a 2 possible, leave it at 2 possible, and we'll continue that tomorrow. What I want you guys to start on tonight is on page 803, 20 through 32, even. Okay. Just a few of these to start with. The first thing it's going to ask you to do is it's going to give you the values themselves. You're going to tell whether or not which scenario it's going to come across. If it's going to be one of the angle sides or angle side angle to start with, go right into law signs and solve it out. If it's not, then you have to go through the little cheat sheet thing that I gave you. All right?
You're going to need to use that on the test.
I haven't decided. I haven't decided.
I decided for you.
Well, thanks, guys. You're awesome.